Okay, episode 3 of our interview on the anechoic chamber. We're going to focus on acoustics and materials. So, number one question that we get asked when we have shown our old anechoic chamber in the past is the size and how it's determined and how big do they need to be. And there are obviously a lot of variables to be calculated with a given goal. Can you tell us a little bit more about the size versus the goal calculations?
Basically, anechoic chambers are often used for automotive, for example, if you measure a motor or so on. So there you often need a lot of volume, a lot of space to calculate the sound energy around the motor in a certain distance. For electroacoustic measurements, as we do it, actually size is not so important. Your most narrow dimension defines how long or how low in frequency your anechoic room will work, but always in combination with the absorption. So the way the direction we got is put a lot of absorbing material in, and then actually the size can be quite minimized to fit our needs. Obviously we have available space, so we need to use the space we have.
Okay, so how, given that we're going to measure this from a distance of 1 meter, how is that achieved? What kind of space do you need?
Right.
In front or behind the microphones and whatnot?
So basically we try to have a clearance zone of around 1 meter of the microphone, and we will have more than 1 meter absorption material on each side. So that means both sides, ceiling, floor, every dimension. And maybe I can show you what material we are using.
Okay.
So it's actually also, I wouldn't say a low-cost version, it costs a lot, but you can take special material you find in buildings, and simply by using this material in a way that you have more open surface where the sound is coming from. Just imagine this room will be full of these plates, and the plates will also have different lengths, so to make sure you have no flat surface but some diffusion. And on the ceiling we will actually have special kinds of foam wedges. On the sides, actually, it doesn't matter too much because you can also put a carpet in front of them, which we might do. But on the ceiling, you cannot do that so well, so that's why we use wedges there. And the wedges also have the good effect that you have your impedance of your absorbing material increasing over the length. So you first start with a very narrow material, basically, and it increases in dimension. So that's why wedges are better, and we are using them for the ceiling.
Okay. So again, once all the gear is moved in, we're going to close this up and you'll install the ceiling and then I guess the front door and the wall to get in here.
Right. Okay. Special big door.
All right. Thanks. That's it for episode 3. Stay tuned for episode 4 if we do one as we go forward. Bye.